Hello, everyone, and welcome to the second episode in our Twitch series on building web-based augmented reality apps on AWS. I'm Chris Schultz. I'm a specialist solutions architect here at AWS, and I'm joined as usual by Jake Smeester, our content creative specialist, who happens to be remote today. Jake, how are you doing?
I'm good, Chris. Thanks for letting me tune in remotely. I got stuck in Denver due to some weather, so we're doing this remotely for the first time. So, first time for everything.
Yeah, hopefully things go smoothly. But we're pretty excited. Today we're going to build on top of what you saw in our first episode on augmented reality, which you can access in the archives on our YouTube channel if you haven't seen it yet. So we're not going to revisit the basics that we went through in that first episode, but instead we're going to add some new functionality that you might need in your augmented reality applications. Jake, is there anything you wanted to add to what we're going to cover today?
Yeah, so this is mainly going to be led by Chris, and I will be monitoring the chat room and just throwing out some questions as needed. And so if you got any questions, I will be making sure to cover those and also calling some of those out to Chris if we need to. I believe that we might also be joined by some eighth wall people. If you are there, please make sure you call out because, yeah, we got some great people from eighth wall that can really help us out and answer some really good questions. So, yeah, it's all yours.
Okay, we'll dive right in. So the feature that we're going to be adding today is the ability to give user control over the scale and rotation of the augmented reality scene. So we're going to add a pinch gesture for managing scale and then a rotation gesture to allow rotation. So a good place to start is probably to look where we ended on our last project. So I'm going to show you that on my phone as a reminder of where we left off. And one of the things I want to point out here, we're going to go ahead and load up the scene through our Safari web browser. And I want to talk a little bit about the concept of scale in AR. So when I place this airplane model on my desk here, you'll notice its scale is pretty small. Its wingspan is about as big as the smile on the AWS logo here. But if I go ahead and reload the browser, and this time I'm going to place it on the floor rather than on my desk. I'm going to tap to place, and you'll notice the scale of the model is much bigger in this context. So in augmented reality, it's important to kind of take scale into consideration when you're building something. So for a lot of applications, that means you'll want to give your end users control over the scale of the AR content. So that's what we're going to focus on now. One more thing that would make a good starting point for us to dive into this is take a look at how pinch gestures work by default in Sumerian. So we'll switch back over to the phone. I'll load up the app one more time here. So if I use a regular pinch scale gesture in my browser now, watch what happens. So it freezes the frame and it scales up the whole image. So it's no longer rendering the page in real time. It's sort of taken a snapshot and just zoomed into the web page. That's the default behavior that you'd usually want on regular websites, but it's not what we want for this particular experience. So our first task is going to be disabling that default scaling behavior in the browser itself. So to do that, we're going to switch back over to Sumerian where we left off in our last project. If you're following along with this video and want to continue building as I build, just note that we'll make the tutorial article, which includes all the basic steps to get you to this base starting point. We'll link to that in the chat. I think Jake will do that. And you can also watch the previous, the archived version of this video on our YouTube channel. So I'm back in Sumerian, back in the scene exactly as we left it last time. So what we want to do is we want to change the scaling behavior, the default scaling behavior for the browser. Luckily, this is really pretty easy. We do it through CSS. So I'm going to select the global CSS that's used in my scene here, and I'm going to open that in my text editor. So we just need to add one little bit of CSS that tells the browser to ignore those default scaling gestures. And the way that CSS looks is this. there's a top level HTML element that all of our Sumerian content is wrapped within, and it has the ID Sumerian. So that's what we're addressing here. And we're just going to use the touch action property, and we're going to set it to none. So this gives the browser a clue that we want to handle any touch actions rather than the browser handling them for us. So I'm going to go ahead and save that. Then I'll switch back over and republish my scene. And then we'll switch back to the mobile view to take a look at the result. So I'm going to reload the page here. So now when I tap in place, now I'm going to use that pinch gesture again, and it does nothing. So that's exactly what we want. We want to be able to implement our own handling for the touch events. That makes sense, Jake?
Yep, and I also have added in a few links. So there's the previous link to the last episode, as well as the quick start augmented reality tutorial that really covers everything covered in the first episode. And we also just had a question about the model. I'm not going to try to pronounce it, but we had a question about the model. A bit curious, is the plane a Blender 3D object or some IMG or image? So I believe this is an FBX file.
Yeah, this from Sketchfab website and is licensed,
which I also just included in the chat too.
Yep, it's licensed under the Creative Commons, so anyone is free to use it. I'd say go to the Sketchfab site to get a copy of it if you'd like, or I made some slight modifications to the look of it so that it looked extra good in Sumerian, so you can always get that version by following the tutorial link that Jake posted.
Cool.
Okay,
yeah,
so
otherwise we're all good.
Yeah, let's get started on implementing these gestures. So something to know about gestures and browsers is that the web browsers are capable of tracking events for individual fingers. So that's all the touch events that are supported by HTML. But it tracks each finger individually, and it's up to a developer to come up with there's no concept of a gesture, so no concept of how that finger position changes over time relative to other fingers. So in order to get that sort of gesture support, we can either write a lot of JavaScript on our own, or we can be lazy and look to the open source community to find someone who's already done it for us. So I'm going to be using an open source gesture recognition library in JavaScript that is called Hammer.js. So if we switch back over to my computer, you'll see the Hammer.js website. There are other options out there if you want to try them. I've used Hammer.js on a couple of projects, Sumerian and non-Sumerian, and I've found it fairly easy to work with. It works really well at recognition and is pretty flexible. So that's what we'll use for our basis here. And this is one of those great things about Sumerian, that because it's based on standard web technologies, it's really easy to integrate third-party libraries that maybe weren't even intended to work specifically with Sumerian, but you can take advantage of them. So to add the Hammer.js library to our project, what we want to do, we need to have that Hammer.js file hosted somewhere. We could either choose to host it ourselves on our own servers, or an approach I like is to just use one of the many content distribution networks out there that already host open source projects. So we're, for this example, going to use CDN.js, and I'll just do a search for Hammer. And we see it show up right here. So Hammer 2.0.8. So I'm going to copy the URL for that hosted library and move back to our Sumerian editor. So we're going to do our gesture support through scripting rather than state machines. State machines are very powerful and can let you build ideas very quickly, but they also have some limitations. So for this particular type of functionality, it's going to be easier if we write it through code. So we need to decide where we want to place that script. So I'm going to select our AR content entity. You'll remember from last time, that is where the model lives and the lighting for our scene, and really anything that you want to exist in the AR space. So it makes sense that when we want to scale or rotate our AR content, that should be the entity that we're modifying. So I'll select that entity and we'll add a new script to it. I'm going to choose the preview script format. So we have two different types of scripting syntax supported in Sumerian. We have what we call the legacy format, which has existed from the start of Sumerian. And we have a newer format that we currently label as preview. It was launched over the summer, and it gives you a little bit more powerful way to work with implementing your features in Sumerian. So we'll go with the preview format for today. The first thing I like to do whenever creating a new script is give it a meaningful name. So I'm going to click right on the script label here. That opens up the properties panel for that specific script, and I can rename it right here. So we'll call this gesture control. Then I'll open that in our editor so we can get started. It starts out with a little sample script. We can go ahead and delete that because what we're going to be building is unique to our application here. The first thing we need to do is link in that Hammer.js library into our project so that we can access it. So that's what this external resources section is in the script editor. It lets you link external libraries into your project. So I'll paste the URL that I copied, hit the plus button to add it to our project, and then hit the save button to make sure that that change has been saved. So now we're all set. Now we can start writing code that leverages that library. The first thing we need to do to use Hammer is create what's called a Hammer manager. So I'll use this code to do it. And the Hammer manager takes a single argument, and that is a reference to an HTML element that you want to be actively listening for touch gestures. So we want our whole application to listen for touch gestures, so we'll use document.body as the HTML entity. So now we have our Hammer manager, sort of the core framework initialized. Now we can tell it what sorts of gestures we want to pay attention to. So we'll start with the pinch gesture to do our scaling. And then the only thing we have to do to get Hammer to start actively tracking pinch gestures is call Hammer add pinch. So what this code has done is it has initialized the Hammer manager. It has initialized what's called a gesture recognizer. So it's a piece of code that's specifically for recognizing pinch out and pinch in gestures. And we've told it that we want to make that recognizer active. So with this, our application can now start listening for special pinch events. So that's how we're going to tap into this functionality. So we'll start that by doing, let's add a section here called scale gesture. So I'm going to use Hammer on, and we tell it what event we want to listen for. So we want to listen for all pinch events. And then we define a handler function that should get run anytime one of those events occurs. That looks like something like this. So that handler function is going to receive a reference to the event or the gesture itself, which provides all sorts of detailed information about that event. So let's take a look at what kind of information we get for those events. So this is a list of all the properties that will be a part of that gesture argument. There's a lot of interesting stuff here, but we really only care about a handful of them. So I'm pruned down that list a little bit to just the ones we care about, the ones that we'll find interesting. So we can get information about the center point on the screen for where the gesture actually started. We can get a definition of the angle. So for example, when you're using a two-finger gesture, it's the angle between your two fingers. The distance would be like the amount of distance between your two fingers during a pinch. It translates that distance into a scale value for us. And it translates the angle value into a rotation based on 360 degrees. And then the last two elements here are the type of the gesture. So this whole gesture class is sort of for all pinch events. And then in this particular example, it was a specific type of pinch, which was a pinch out, so spreading the fingers apart. So those are the properties that we'll get to play with in our code here. So
Chris,
let's go ahead and, yeah, go ahead.
Can I ask you a question? Yeah, so you're looking at a lot of different properties. Just for, I guess my main question is, whenever we're doing like a pinch sort of action on our phone, whether it's for, I don't know, anything else really, is that all those different properties, are those being registered? Is that common? Because it looked like sorry, I missed it actually, if you deleted those or not. It's like some of the other ones, but there was a lot more available, correct?
Yeah, so what I showed you first was all the properties that are actually available. But a lot of these are properties that we won't find particularly useful in the way we want to implement gestures, but might be useful in a different type of case. So this is
what would
really
be one of those cases.
So let's say there's some information in here about the exact time that a gesture started and the duration of the gesture. So perhaps if someone is doing, or actually here's a better example. There are some velocity values in here that tell you not only, like, let's say it recognizes a swipe gesture, not only that it's the finger is swiping, but it tells you the speed that the swiping is happening. So you could use that to drive some sort of change in your application.
Okay, so all these properties aren't necessarily native to your phone. Well, I guess they could be native to your phone because they're available on the phone, but they're not native to a web browser necessarily.
That's a good way to put it. Yeah, these aren't native to a web browser, but they're very similar to the sorts of events that do happen like in native mobile apps. They're the sorts of properties you could get access to. So this just provides them to a browser-based app.
And the reason I bring it up is because it's just fascinating that much data and information is going on with just simple gestures.
Yes,
just interesting how complicated it is.
It is. That's why I didn't want to write this from scratch, because it does get really complicated really quickly.
Totally. Okay, go ahead.
Okay, so we're going to start with a simple implementation of our rotation gesture. So in this new preview scripting syntax, the way I change, I'm sorry, this is scale. The way I change scale is I get a reference to my entity, and then it has a scale property, and that scale property will have X, Y, and Z values. So I want to set all of those values to whatever the pinch is telling us they should be. So I will do that by doing calling a function called setDirect, which lets me pass in 3 values which represent X, Y, and Z. And for that, we'll just use gesture scale for all 3 of those properties. So it looks something like this. So we're just setting the direct scale of the entity. So let's save that and take a look at it on the phone after we republish here. So I'll reload the browser so we get the latest published version. So I'll tap to set the plane in place, and now I'll do a pinch out gesture, and it scales our plane up. So that's exactly what we want. But I want to show you a little hiccup in what we're doing. So I'm going to set my fingers on the phone and do another very slow scale up. So I've set my fingers on the phone, and you'll notice it immediately reset to its original size. Now when I spread, it will expand it again. But that's not what we want. We want to be able to do multiple pinch to zooms or pinch to shrinks and not have it keep resetting to its original scale. That's what we'll address next. So the reason that it's doing that is when I touch my fingers to the phone, it's going to automatically set that as 100% scale from a gesture standpoint. So instead of in our code directly using that scale number to set the scale of the entity, we want to make note of the starting scale of the entity, and we want to add to that scale or subtract from that scale based on how much we've pinched. So let's switch back to code and do that piece. So we have to get a little bit more complex in the code here, a little more sophisticated. One of the things we need to do is we need a variable that we can store the original scale in. So I will call this base scale. And what we want to do is when the gesture first starts, we want to record what the current scale of the entity is. So to do that, we need to tap into a different Hammer event. We want pinch start as the event that we respond to. So when we're in the pinch start, we just need to record that current scale. So we need to set that base scale to the, this is the scale of the AR entity. So CTX entity scale. And I'm going to call clone on that scale object. The reason I do that is this scale value is going to change over time, but we want to capture a snapshot in time and make sure that it doesn't change from the time we capture it. So by doing clone, it will make a copy of that value to ensure that it doesn't get changed. So this gives us the base scale value to start with. Now we just need to update our other event handler, our regular pinch event handler. So we're going to calculate what the new scale should be by taking the base scale. And I'm going to clone that value again because we don't want to accidentally change the base scale value in this line of code. And then we can apply a scale to that value. So this essentially becomes a scale relative to what its current scale already is. So if it's, let's say it starts out at 200%, and I tell it to scale 50%, it will scale to 300%, for example. So here we just use the gesture scale value. That gives us our new scale, but it's always guaranteed to take the original scale into account. Then we can set the scale directly on our entity. Using this line of code. Hopefully that makes sense. Let me know, Jake. Keep me honest if this it's a little confusing to follow at first. I recognize, but
no, I think it makes sense. I guess I mean the idea is that if you're constantly updating it, it needs to be able to scale based on the last scale value, right? So it's just constantly cloning, updating, cloning, updating.
Yeah.
And so I guess the question about is there any need to worry about like time it takes? I mean, I know you mentioned that when I asked the question a bit ago, but so if you make a pinch to increase the scale, does it always follow just your fingers, or does it just is there a way to control how long that takes or how short it takes, or does that just kind of happen naturally and it just really follows your fingers as you do it? Maybe that it's kind of hard to explain virtually.
In this case, it always follows your fingers exactly. So if I expand them a little and then pause, but then continue to expand them, the scale is going to follow that same pattern. Unlike maybe in some applications, it might make sense where you want a quick scale to kind of like open a document or open a view or something like that. But in this case, it's one-to-one sort of mapping to your fingers.
And that's just built in Hammer.js.
Yeah. You could do the other form with Hammer.js using some of those other properties, though, if you wanted to.
Right. Gotcha.
Okay, so let's republish this, and we'll take another look at it. Okay, so now I'll place the plane, and now I'll scale it just a bit, and now I'll touch my fingers again and scale it up some more, and it picks up right where it left off. So now we have the exact scaling behavior that we really want. Cool. Any questions in the chat about that progress, Jake?
No, that's it seems like everybody's following along.
Great.
Yeah, no, we're all caught up. We're good.
Okay, so we'll move on now to the rotation gestures. So very similar setup to what we did for pinch. So we just need to create one of those gesture recognizers. And we need to add that to Hammer for tracking.
Kind of says you're getting this set up. Is there anything inherently different between rotate and scale?
There's
just
not
from like a high level view?
No, it's going to look very similar, the process we follow. You'll also see there's a little different quirk that comes in the mix with rotate, but we'll explore that in a moment here. So yeah, just like we did before, we'll just listen for the rotate event from Hammer. It's going to pass us that same gesture object, which describes everything about that gesture. And here we'll take another simple implementation as our first pass. So we'll use entity, rotate, and we just want to rotate on the y-axis, which is the vertical axis. So I'll do rotate y equals, and then gesture, let's see what it was called. It was called rotation. So we'll save that. Give it a publish. And take a look. Okay, so I'm going to place the plane. Now I'm going to set both fingers on and then start to twist my fingers. We'll see what happens. Looks like I've still got just scale but not rotate. So let's go back and fix that. So to get multiple gestures working in Hammer, it's because pinch and rotation gestures to the phone look like the exact same gesture at the start. They both involve touching two fingers to the screen. We have to give Hammer a hint that we actually want it to be paying attention, that it could go both ways. It could turn into a pinch gesture, or it could turn into a rotation gesture. So to do that, we just have to add pinch, recognize with rotate. So we're saying these two gestures should be able to coexist and should be recognized at the same time. They both can be active at the same time. So I think that's what was wrong with it, but we'll give it a check and make sure. Okay, so we'll place the plane, and now I'll rotate, do a small rotation. I'm still getting just, okay. There's probably an error in my code, so let's take a look. Okay, so we create the rotate, we add it to Hammer. Aha, I think I might know what it is. No. Rotation and not rotate for the entity property. That was the mistake. Okay, third time's a charm. Okay, so now my rotation is working, but you'll notice that even just subtle rotations of my fingers result in the plane spinning wildly. I've got to move my fingers really slowly to get it to rotate at a decent pace. So the reason that happens is because we have to pay attention to what units our angles are in. So in Hammer.js, angles are described in degrees, so 360 degrees in a circle. For the entity rotation property, angles are described in radians. So we need a way to convert our degrees that Hammer's giving us into radians. Now, if you don't remember your geometry formulas for doing that sort of thing, that's okay. Sumerian has you covered. If we take a look at our documentation and just do a search for degrees, you'll see that we have a radian from degrees, or rad from deg, function that we can call to do that conversion for us. And that function is a part of the mathutils class, which mathutils is in the math package. So we can use that to do the work for us. So we're going to be using this a couple times. So I'm going to save a short reference to the mathutils class here. So I'll do const mathutils equals, and it was in the Sumerian package called math. So we just do s.math, mathutils, just like that. This is just giving me a shortcut, a one-word version of a way to access it versus having to type this every time. That's all we're doing up there.
Chris, I have a question, and I'm totally asking for people and not myself here, because I'm sure people don't always remember geometry from high school. What is a radian versus degrees?
So
is there a simple way to understand that?
Yeah, a radian is just a unit of value that describes, like to go all the way around a circle, you will go from 0 radians to, it's based on pi. So it's, I think 3.1415 radians will bring you back to the top of the circle. So that's why the difference in measure. But again, I don't even remember that stuff, which is why I love that there's little helper functions in Sumerian to help us do that.
Perfect. But that would also kind of help explain why it jumps.
Exactly, because we're in a big number and it's expecting a small number. Exactly. So we just use this to convert. And one thing you may have noticed, although if you couldn't see my fingers, it might not have been super obvious, is it was actually rotating the opposite direction from the way my fingers were rotating. So we can fix that easily by just putting a minus sign in front of this value. So let's go ahead and save that. And take another look.
And while you're setting that up, I'll just make the comment that in the last episode, we kind of went through the whole process of how do you get this model into a Sumerian scene and then create using 8th wall along with Sumerian, creating a published application or published URL that Chris, as you can see, is accessing right now. So if you're wondering if you're kind of new to this, how we made that jump from Sumerian to an augmented reality app on his phone, that was explained in the first episode. And also there's a tutorial that we've posted once, but I'll make sure I'll post that again here in a second.
Yep. Okay, so let's take a look and see if we've got this working here. So I'm going to do a small rotation, and now it obeys much more accurately what I expect from the gestures I'm doing. And you'll also notice that it lets us scale at the same time because we did that recognize with function to get pinch and scale working together. But there is still one issue I'd like to fix with rotation, and that's, so I'm going to place my fingers on the phone in a pure vertical orientation here, and you'll notice the plane snaps to face me. Then if I tap on the phone using sort of a 45-degree angle, the phone snaps to a different angle. So the way that angle property of the gesture object works is it actually tells us the angle between the fingers, not the angle representing the amount they've rotated since they first started. So much like the way scale would always reset to 100%, our angle is starting wherever the angle between our two fingers is. We don't want that. We'd rather have the plane start at its whatever angle it's currently facing and only turn when we start to move our fingers. So that's what we're going to fix next. So much like we did before, we need to record, in this case, a couple values right when the gesture starts so that we know how to apply them later. So we're going to use two values. We'll call one base entity rotation. So this is the rotation of the entity when the gesture first starts. We'll call the other base gesture rotation, which is the angle between the two fingers when the gesture first starts. And from those values, we'll be able to do what we want to do. So we need to record those values when the gesture starts. So we'll use rotate start as the event. I'm going to break this into a few lines so that it is a little easier to follow and easier to read. So the first value we're going to get is the rotation of the entity in radians, because that's what it starts out as. And again, we are only concerned with the Y rotation, the Y axis. So once we know what the entity's rotation is on the Y axis, we will save the base entity rotation as degrees, because again, that's what Hammer expects. So math, utils. So here we're going the opposite direction we went before. Before we were going from degrees to radians. Here we're going from radians to degrees. So that gives us a representation of the starting direction that the AR content was facing. And then to determine the starting angle between the fingers, we just set base gesture rotation to the gesture rotation value. So now we can get rid of our inferior solution in the regular rotation handler. And again, I'll break this into multiple lines just to make it easier to follow. So we're going to start with I'm going to call this rotation delta, or in other words, the amount of change in rotation that the fingers have moved. So that will just be whatever the current gesture rotation is minus what our starting gesture rotation was. That just tells us the amount of change that has happened since the gesture started, in degrees in this case. Then to determine how much the actual AR model should move, we're going to take the base entity rotation and we're going to subtract whatever that rotation delta was. And finally, we're going to convert that value to radians, which is what Sumerian expects. So this will be just the amount of rotation that should happen to the model, and it's expressed in radians, so we can set that directly on the entity. Let's save that and see if I typed it all correctly. Republish. Reload the browser. Now I'm going to place two fingers on the screen at a slight angle, at a 45-degree angle. And we'll see that the plane doesn't change its rotation at all, which is good. That's an improvement over last time. And now I'll slowly rotate clockwise and then slowly rotate counterclockwise. I can keep doing that in small stages, and it works just like we want it to. So that's our functionality. That's the way we add scaling and rotation, or one way we can add scaling and rotation to an AR experience in Sumerian. So what questions do people have? Any other ideas or thoughts? Yeah.
Yeah, I was just looking at the chat. One question I have is, if you wanted to add rotation to the X and Z axes as well. Would you need to duplicate all of that code just using Y, or any guidance you can provide if you wanted to add in X and Z?
So I think probably the most challenging with rotating on X and Z is how you would surface that through the user interface, like what the user experience would be, right? Because if you only want to rotate on X or Z or Y, then you could just use the code as is and change which axis you're referring to. But if you want to give the user to change Y, X, and Z all at the same time, you would need more than a single rotation gesture, right? You'd maybe need some sort of mode button that puts them in X rotation mode and then do the gesture, and then Y rotation mode and then do the gesture. So it's a little bit more of a user interface challenge than an actual coding challenge. But all of the code that you saw there would be the exact same type of code you would write for all the other axes.
Gotcha. And we did have a question about, somebody said, who is presenting? Chris Schultz is the main presenter. I'm Jake, and I'm the one who's kind of monitoring the chat room. Another question about the app key shared between browsers. I'm trying to think what this would be referring to. Is that the app key created by 8th Wall?
Probably, that would be my guess. Yeah, so as a reminder, when you're in development and your app isn't launched to the public, you need to, and this may be what they're referring to, you need to register the device or the browser that you're going to view the content. You need to register it through the 8th Wall portal using the same 8th Wall project that the app key you've used in Sumerian uses. Now you can register multiple devices or multiple browsers on the same device to that project without issue, but you do have to explicitly authorize every browser and every device that you want to use during your development and testing using that mechanism. Once you launch your app to the world, devices no longer have to be authorized against specific applications.
Yeah, that's just a wise limitation put in there for when you're developing, like in this case. So, all right. Let's see. Somebody else is saying they are studying with this in the background because they're studying for their solutions architect certification. Good work.
Awesome.
Great. And then the same person just put a long question in. Okay, so if you want to look at, this is a long question. I don't want to just read it. It's a little bit long. But people asking questions about what we were just talking about, getting your device authorized. All that, there's a lot of guidance in the tutorial that I've posted a couple times. I will post it again. But there are some things you need to consider when you're trying to get your device authorized, because there's some limitations and some settings on your phone and Safari that you need to take into account. So just make sure you're following those.
Yeah, and I would say your best reference there is go straight to the source. 8th Wall has a troubleshooting section in their documentation which covers device authorization. Anything we mentioned in our article, we just borrowed from that documentation. So I would definitely go to 8th Wall as the source, and they have very helpful people in their own Slack workspace and on Stack Overflow and a few other ways you can get a hold of them. So if you're having trouble with device authorization, definitely reach out to the 8th Wall folks.
Right, great. Let's see. Also, so I think that pretty much covers this one, right? Okay. So I mean, it's just so interesting how much work goes into just gestures. You know, it's like when you're kind of new to this sort of thing, there's a lot more that goes into what you do and use all the time on your phone. Exactly.
Yeah, it's pretty complicated stuff. It makes it a little easier using third-party libraries like Hammer, but you still have to write a little bit of code. The good news is this code can apply to any AR project, right? Once you've written it once, you now have code that's easy to copy and paste to other projects.
Right.
I think one thing I wanted to mention, so we mentioned at the start of the video that this is a series, right? So this is episode 2. We're planning to bring you episode 3 in the coming weeks, and we have some ideas for what we want to show you, but I also would love to hear any suggestions people have for what they would like to see next as far as general purpose kind of AR interactivity or functionality. You can obviously paste questions in the live chat now, or you can join us on our Slack channel and post your suggestions there. And we'll take a look at those and see if we can incorporate some of those ideas into our next video.
Right. So yeah, a few things about that. To reach us, if you have any questions for either myself or Chris, you can find us on Slack, which I'm putting the link in there. So join Slack. You can find us. You are AWS Chris. I am AWS Jake. And a few other ways to do it. We're going to be putting this video here shortly up on our YouTube channel. So if you want to check out our YouTube channel, you can also ask questions via comment in the YouTube channel. And so we can do it that way as well on that version of this video. So a few ways to reach out to us. So I think that covers it. The next video that we're planning, the final episode we're planning on doing is, currently we have it scheduled for March 3rd. And make sure you're checking up, either through Twitter or Slack and all those different places. But that's where we have it, just due to some travel and personal time. That's when we're slated to have it next. So in about a few more weeks. So if there's nothing else, I don't see anything else in the chat, I think that's probably good. Chris?
Fantastic. Yep, I'm good. Thank you guys for joining. This has been fun. I hope you learned a lot.
All right. Thanks all. We'll see you soon.